Okay, there are practical examples of static electricity you encounter every day. You can see it in where?
So I feel it before.
You rub your socks on the carpet, I guess, I don't know.
You rub your socks on the carpet when you're walking on the carpet. You feel some static electricity. A balloon on your hair. Where else?
I kena shock.
Where?
Like here. Like my hair.
The lining. Is doorknob considered?
Huh?
Doorknob.
Doorknob. So when you touch a doorknob, you get where? Singapore.
Singapore.
Where?
My aircon room.
Your home aircon room. Okay, you see, you notice he said his home aircon room, right? So
Aircon.
So you go and touch this doorknob now, will you get
No.
shocked?
No.
Not cool.
Try.
Okay, Brett, go and try.
Wow, later
Then
You won't die.
you down, then Warren will come here and give you CPR.
I don't want. Later he kiss me.
Yeah, the moment he comes close to you,
No,
instantly
no,
wake up
Valentine.
already.
Not
Okay.
my Valentine.
Tomorrow he'll be your Valentine for tomorrow, Warren.
No.
Okay, first case, Warren. Or
No.
sad case. Okay, so he said in an aircon room you touch the door. Okay? But if in a normal case, most of the time Singapore very hard to get electrostatic shock. Unless you deliberately you say you're going to use a balloon right or something like that. Other instances also in Singapore, certain places people will tell me they get electrostatic shock. Like where else?
The phone, I hold phone, then suddenly have like
The phone.
yeah, I just hold phone, then
That is very
someone's hair
unusual.
on my hand.
Where? Certain places, more likely,
Computer area.
even going down the MRT, escalator, when you are holding on to the escalator, you go close to hold on to the, what do you call it?
The metal.
The railing.
The railing, right? You may encounter it as well. Yes.
I got
So,
before.
all these are electrostatic, correct. And then the biggest display is what? What?
Lining.
Lightning, correct. When you got lightning, that is the biggest display of electrostatic.
Before it gets struck.
Your hair will all stand up before you get struck. Yeah, you're right.
Why?
Huh?
Why?
I will tell you why now. Okay, so this chapter very interesting in a sense, right? So you a lot of instances. Okay, so great, you're just in time. Just started. This one should be oblivious. See, they touch the doorknob. Nothing happened. Okay lah, quick sit down. Quick, I just started.
So is there a way to randomly get static electric shock?
Can. If I have a, I can show you. I did some electrostatic experiment over here in this room before.
Try, I want to see.
Yeah, I managed to bend the water. Yeah, I bend the water. You know, water should just fall straight, right? Then I turn on the tap there, and I cause the water to bend.
Isn't that wave?
It's not wave, Okay, so
I remember my teacher talking about it. It go like that. He put the radio, then after that the water go.
I'll bring book.
My bad.
Your bag. Okay, so electrostatic, we talk about the most common example. Okay, and I'll give you the ideas behind it. Lightning. Right? How do we get lightning? Okay, why? Because things get charged. So the cloud gets charged. Okay, when it gets charged, we either say it becomes what we call negatively charged or positively charged. Okay, there are two types of charges. What are the two types of charges? Okay, let's fill this up first before I talk about the lightning. Positive charges and negative charges. Okay, don't tell me there's one more thing called neutral charge. There's no such thing as neutral charge. Okay, when you say something is neutral, it simply means, what do you think it means?
Neutral.
It doesn't mean no charge. It means equal number of positive and negative charges. So equal number of positive and negative charges. So in a normal circumstance, everything is neutral. So this calculator is neutral. Okay, that means the equal number of positive and negative charges. This one water bottle, okay, the visualizer, everything here is neutral, right? But when something is what we call negatively charged, what it means is that the body has
Hallelujah.
Brett, your Valentine has arrived.
Oh, Valentine's are sweet, you know.
Brett's Valentine has arrived. Yeah, boy. So when something is negatively charged, it has more negative than positive charges. Okay? Take note of this. More negative than positive. It doesn't mean that it has no positive charge. It just means it has more negative than positive. Alright? So, on the other hand, if something is positively charged, it has what? More positive than negative charges. Okay, so you know there are two types of charges, positive and negative. Right? Neutral, equal number of positive and negative charges. Okay? Next thing, lightning. Right? Lightning means the cloud has become charged. Anything that is charged will want to become neutral. That's why you got lightning. That's why when you touch your doorknob, you get this small shock. That's why when you go down the MRT escalator, you touch, sometimes you also get this shock. Okay? Right? This is because anything is charged want to become neutral. So this cloud here is charged. It wants to become neutral. How does it become neutral? Okay? It has to give up its extra negative charges. Right? So you see, there are negative charges there. It needs to give up. Okay. So first thing, remember, anything charged want to discharge itself. Second thing, only electrons can move. Right? So here, let's say I got extra, how many? I got extra 9 negative charges. So how many must it give up in order to become neutral? 9. It must give away 9 extra. So where is it going to give? The earth. So then this guy say, before you get struck by lightning, the hair can stand up. See, so
why? So then,
so like this,
you always get struck by
see, why the hair stand up? Is the same idea as similar idea to magnetism. You know a magnet, if I put one nail here, here's a north pole of magnet. This can cause this nail to become a magnet. This pole of this magnet will be what? South. You all know, you learned before, primary school, right? So in the same thing here, here this negative charge can what we call induce a positive charge here. Okay? Right? And then what happens? This one when we come neutral, it will strike a lightning going down. So the lightning goes down. Then it becomes neutral. Okay.
Sir, how to remove your hair standing out?
Just walk out like this.
You gotta go away quickly. Now, more often than not, you will see lightning always coming down. But you can search YouTube, you will see actually there are cases where the lightning go upwards. Like that.
Why?
Why?
How?
You see, in this case, the cloud is what?
Positive.
It has 11, we can count, it says extra 7 positive charges. So positive charge cannot go down to the earth. So from the earth, what must come up? Negative. How many of them? 7. So 7 extra electron must go up in order to make it neutral. Neutralize it. Okay, so it's very rare, but lightning can actually go up, but very rare. Okay, more often than not, it's coming down.
So it go like boom.
Yeah. Okay, so if Warren is standing here, you will see the lightning come from Warren's finger up to the cloud. Okay. But after that, you won't recognize him already lah. Okay. Then after he'll be on the floor. Then Brad will have to give him CPR.
No.
Just now he
Cannot.
you want to demonstrate CPR on Warren?
No. Cannot.
Or Warren, you want to demonstrate on him?
Don't want.
No, right? I don't think you want to. Okay.
I want to.
Okay. I also don't want to see. I don't want to know. Okay. So charge. Okay, there's this formula for charge. Actually appears in your electricity chapter. Okay, I can tell you now. The charge formula is Q equals IT. Okay. Q stands for charge. Okay, and the unit for charge is capital letter C, Coulomb. Okay, not Columbus, Coulomb. So the unit is called Coulomb. So you got something called 5C. Coulomb. Alright? So SI unit for charge is Coulomb. I stands for what? I. When charges start to flow, what do we have? We have current. Okay, so current, and the units for current is, you learn from lower sec, ampere, capital A, A, like that. And then of course T is time lah, which you must remember is seconds. Okay. Okay. So there's a formula. Actually, you don't need this formula until the next chapter. Okay. But
So that
I can tell you now. Okay, so what are the important ideas? What did I say? A few things I said just now, which I hope you remember. Okay, the important idea is what? Only what can move?
Electron.
Only electrons move. Okay, so you don't say things like, like that. The positive charge go down to the earth. No, it is not. It's the electron that went up. Okay? Okay. Then the next thing, what else did I say? Anything charged? Anything charged what? We want to
Neutral.
be neutral.
Yeah.
Okay. So just now you said Javier say he's in the aircon room, you can get this effect. How come the charge can stay there? Because aircon makes the room very dry. So when it's dry, it's very hard for the charges to go down to the earth. That's why in Singapore you don't get so much of this electric shock. But if you travel overseas, especially dry countries, usually cold countries, every time, okay, open the doorknob, the car door, you will get electric shock. Right?
Is that XE charged?
Anything charged.
Oh,
Right. So in Singapore you don't get so much effect because Singapore very humid. So being humid means a lot of water vapor in the air, so the charges go down to the earth easily. So you don't get so much electrostatic shock.
So can I ask something?
What?
How come at the petrol kiosk got like a tiny pad then you say touch to release the static?
Real one. I think it's real one.
Why they put it
So
there?
that one is real one to be neutral, right?
We want to be neutral, yeah.
Real one.
Okay. Wait, later I tell you. Okay. The one I can send you one interesting video, you can see it. Alright, how do things get charged? Okay, one way is by friction. Okay, so friction means what? Friction means, okay, for example, the cloud, how it gets charged. The cloud is charged by the wind. The wind blows against the cloud, there's friction. Okay? Or, so when you fill it up or when you explain it goes like that. Charging occurs when two different materials are rubbed against each other. So friction between the surfaces separates the electric charge such that one becomes
Positive.
Positively charged.
if one is positive, then the other one is what?
Negative.
Negative. You cannot have when you rub two materials, let's say a cloth and a rod, or both become positive. Cannot one. Because the electrons must somehow move from one to the other. Okay? So for example, you got two materials. All these I can show you video. I'll show you a video which I did. What I actually did. Cotton and a polythene cloth. Okay, a polythene, this is the other way around. How come okay, this is the rod. Okay, the rod is made of polythene. Polythene is a plastic. Okay, it's a certain type of plastic. When you rub a cotton cloth, the charge on the rod or the insulator, this is insulator rod, okay, is negative. Then the cloth will become positive. Okay, so what it means is this. So you take a rod, and then this is a cloth, right? If let's say the rod is negatively charged, like that, that means where did the electrons go? Cloth to rod or rod to cloth? Think carefully.
Rod to cloth.
Rod to cloth,
Close to right.
Cloth to rod. The cloth lost electrons. So this one gain electrons, become negatively charged. And since it lost electrons, you have now more positive, right? So this one become positively charged. Understand? No? So it's either electrons go from cloth to rod or rod to cloth. You have to see the scenario. Okay? And then if it's another kind of material called acetate, this acetate will become positively charged. Then the charge on the cloth will become negative. Okay?
So this one memorized.
Used to in the past but nowadays I think you don't really need to Okay, so to explain, if you were asked to explain how the acetate rod gets charged when it's rubbed with a cotton cloth, okay, you fill in the blanks, lor. When the acetate rod is rubbed with a cotton cloth, what's the keyword? What will separate the charges? Friction, yes. First word, friction. Okay, friction will separate the charges such that electrons will move from, okay, now acetate what? Become positively charged. So if it become positively charged, and it means the electrons go from where to where? Rod to cloth or cloth to rod?
Rod to cloth.
Rod to cloth. Why? Because the rod lost electrons, that means they are more positive. So it goes from the rod to the cloth. As a result, the rod becomes positively charged, and the cloth becomes negatively charged. Okay.
It died so soon. I'm sorry, sir. No battery.
It's okay lah. Then you cannot use.
And then 1%.
Very good. Then you won't be using it today.
Wow, the jam was trash, was horrible.
Okay.
All the way from Kallang.
Okay. What's the next line? Only what can move?
Electron.
Write down. Only electrons are free to move.
No signal.
Signal has returned. And they move because, what's the key reason in this chapter? Qing Lai, you better know, tomorrow you're having tests.
Oh, really? Tomorrow?
Unlike charges,
Repel.
positive and negative.
Attract.
Oh, so me and my okay.
Like charges,
Really good.
Brad and Warren,
Do not repel.
repel.
Yes.
Yes.
Thank you, sir.
Like charges, repel. Unlike charges, attract.
My heart just sunk.
Unlike charges, repel.
Okay. Okay, so you draw the electric field is like this. Now you draw equal number of lines. You're going to draw so many on this side, you draw so many on the other side as well. And your lines must touch the charge. Don't draw like that. Don't draw like a sun like this. No. It must touch the charge. And the arrows always point from positive to negative, away from the positive. Okay. So when you draw that time, please use a pencil and a ruler. Okay, so you can draw nicely and neatly, right? Rather than freehand, it looks awful. Okay, so positive charge is just like this. If it's negative,
So the arrow just reverse.
huh?
The arrows flip.
Yeah, everything the same except the arrow direction changes.
So it's very hard.
Yeah. Yeah.
Okay, so very easy to draw. Don't get it wrong, right? Okay. And then when you bring a positive and negative charge close together, Jojo, what will happen? They will what? Attract or repel? Attract. Okay? They will attract. So, how do you draw the field? The field lines will join together. So you see this one, like that. They will join up. And the field will go from positive to negative,
Wow, this is testing my art skills.
which you
Or
Have none.
so the teacher needs to wait line for what?
Huh? When you draw, the mistake you make is one, okay, never draw the arrows. That's the most common mistake, or draw the arrows wrongly. Positive to negative, remember that. Two, a lot of people don't draw here. They focus on the center here. They connect. Or then they forgot to draw on the side. Okay, draw. All round, it should look something like
Wow,
this.
this is giving me bad headache.
This is nothing as bad as drawing waves, right?
Look like
Oh, waves are worse. Never mind.
Different technique, technique.
Okay.
look like a crab.
Wait on, so wait on.
What?
I need to draw.
The length of each line need to be same.
Roughly lah. The length doesn't really matter, but the symmetry does.
Oh, hopefully this doesn't count for N levels.
Okay. Then when you bring two negatives together, one Brad and one Warren, what happens? Repel. So, how do you draw the lines when you repel?
The arrow reverse after they go away.
Ching line how draw na?
Yeah, you bend away.
Okay, bend away. So the emphasis is here like that. Look, I draw like this. Look, how running parallel towards each other. Okay, some people, I gave this an exam before test. I tell you, it's so easy, but people cannot get marked. They just draw like that. Okay, they just literally draw it like this. Not good enough. You need to draw them, the two lines running parallel. Okay, even this also not very nicely drawn. They run parallel towards each other. So implying what? Repulsion.
So, must they be like perfectly symmetrical or like rough as kind of gems?
I mean roughly lah. I mean draw as best as you can lah. I cannot say cannot, right? So you, of course, drawing not so easy, but you draw as best as you can. So as I said, you must make sure you got equal number of lines. Okay, if let's say this one you go and draw how many 7, 8 lines, then this side also must be the same lah, right? And
Like
then
Spider-Man.
after that, after you finish drawing, don't forget to do something.
Arrow.
And how does it go?
The arrow right.
Inwards towards a negative, yes.
Yeah.
Okay, because it's always positive to negative. So it looks something like this. Okay?
The second go down, please.
So then positive and positive then?
Same thing. Exactly the same except what?
The arrow.
Arrows
Oh, arrow.
point away. Alright? So it will look exactly the same. Okay? Okay, so okay, so there are actually some practical uses of electrostatic. Okay, like the one practical use is
Exactly.
photocopying machine. Okay, a photocopying machine actually uses the idea of electrostatic. You don't need to know the exact details, but just know there's an example, photocopying machine, right?
So the auntie that help us print the thing got electrostatic.
She doesn't get shocked.
But
Okay.
the thing have it.
It uses the idea. You won't get shocked. Okay, what's a precipitator? A precipitator
Mixed water.
not mix water. Okay, removes
Sound like a chemistry topic.
air pollutants in a chimney. Alright, so let's say you want to reduce the air pollution. Huh? Like in a factory, yeah. I think I have a question later on this, so you get the idea. So just know, okay, at least 2 examples like this. Okay, one better example, also quite a good example I can think of now is this. Spray painting of car.
Huh? How?
Oh, okay, let me explain. How you use spray painting of car. In a car, you never use hand to paint. It will never look nice. Right? Definitely very uneven and so on, unless you're a very good painter. So what happens in a car? The car body is metallic, right? So the car body is metallic, right? And then they use a spray gun which shoots out the paint, right, onto the car. Okay, so the paint droplets, you can make it positive or negative. It's up to you. So if let's say you choose to make the paint droplets positively charged,
They repel away from each other, that's how they spread.
you must remember your car body. Make it what?
Negative.
Negative. You must make the car body negatively charged. You go and make the car body positively charged, what will happen? You will get painted, right? The
But
paint won't stick on it, it will repel away from the body onto you and then you get painted.
Oh.
Alright? So the advantage of this.
So what? You look like what? A force field around the car, then you shoot paint, you shoot
Yeah,
back.
yeah, you will repel away what?
Oh, that's kind of cool. I also want to see that.
YouTube video.
After you become pink color.
Huh?
Imagine.
Pen?
After you become
Pen
pink.
what?
also the same thing,
I want to see. I don't care about company. I want to see that happen as well.
Okay, so what's the advantage of this? Advantage is that Kaiser, what do you say the advantage is? You will spread out, right? More evenly, and then you save on the paint, right?
Yeah.
Because it will stick onto the car, not onto the floor, the ceiling, everywhere. Okay, so that's a very good example. Alright, another similar idea. Okay, I can write one more. Crop spraying
Crop spraying.
of insecticide. So you see, those Singapore don't have, of course. Okay,
Insecticide have what?
when you spray insecticide using aeroplane, not your
Oh.
spray can one. No. From over the farmland, they spray the insecticide. They will charge the insecticide with a certain charge, so that the insecticide can spread out. Okay, so there's another use. So it's quite interesting, okay, this chapter. Okay, come, next page. We will skip the calculation because calculation normally will be in next chapter. I will skip it first. I will talk about this, which is important. Electrostatic induction. What is induction?
You put inside.
Okay, there's charging by friction, You take the cloth, the rod, rub, there's friction. This one, how you know whether there's something there's induction is when it doesn't touch. You bring this rod very close to it. It's common sense, very simple. Okay, next page. So electrostatic induction is the process where you're charging a conductor without what? What did I just say? Without what? Between the two bodies. Without what? Without contact. Okay? Without contact. Between the charged conductor and the charging body. So you see like this, or you read a question, or you look at the diagram, bring very close, then you know this is induction really, for sure, guaranteed. Okay? You don't say, hey, this is friction. No, it's definitely induction. Okay, so my guideline to help you explain is what I teach this to the express guys as well. They need to explain this as well. First, you explain in terms of electron movement. Remember, I always tell you, only electrons move, not positive charge move. So this stands for my E. Then R, the reason, and then the overall effect. Okay? So, how to use this guideline to answer? Just look at this example. Very simple. Teach you very fast, you will know. So, Jinglai, if this comes out tomorrow, you will know. First thing, label the diagram. On the right side, obviously, is positive or negative? Jinglai? Yes. On the right side, you label positive. If you're going to draw 5 positive on the right side, make sure on the left side you draw 5. Okay, it must be balanced. Alright? Okay, then drawing, normally they ask you, okay, draw 1 mark. Okay, very easy. Then next, they ask you, explain what has happened. Okay, explain what has happened, use my guideline. First, have an intro statement. When the negatively charged rod is brought close. Okay, my intro statement. Okay, like an essay, right? Intro paragraph. Okay, now what happens? So use my guideline, explain. One, talk about E, electron movement first. How do electrons move? Electrons. Okay, don't say about positive charge. Don't say the positive charge move to the right. You say that is wrong. Okay, I keep saying that. So remember not to write that down. So you say electrons move to the... Come on. You want to go back? Better tell me. Move to the where?
Left.
To the left. Correct. It moved to the left of the sphere. Okay? It moved here. That's why all negative, right?
Yes, sir.
That is your first one, E. Okay, so when you explain, you talk about electron movement first. R, tell me why. Obvious, the reason. So easy, remember.
So, because opposite charges.
Don't say opposite, say
because. Because light charges.
Light charges.
Repel.
Yes, light charges repel. Because light charges repel. So, this one negative. All the negative that was here move to the left side, move far away, right? Then a lot of people will stop here. One of the reasons why I introduced ERO to explain for students to explain because they will stop here, or worse, they don't even give reason. Okay?
Yeah.
Oh, the overall effect. As a result, the left side is what? State the obvious. The left side is what? Negatively charged. And the right side? Positively charged. Okay? So you are asked to explain, follow my guideline. Okay, Jinglai, tomorrow you ask to explain, follow the guideline. Haven't finished yet. The thing dropped.
Positively charged.
No. Okay. Now, one more example, then I will dismiss you guys. Okay, So just now you saw, I showed you the video of me, I use the rod, I can attract the paper. How do you explain that?
People will like.
Copy finish, done. I'm going to move.
It's under the name.
You screw it back onto the board. Next question. The positively charged rod is brought close to a small piece of paper. Okay? First, draw the charges appearing on the paper. Kaden, what are you going to draw?
Me? For me. I didn't even do shit.
What are you going to draw? How are you going to draw the charges here?
Negative.
Where?
The paper.
Which part?
The top.
On the top, yes.
That's the rest.
So I draw 3 on the top. I want to draw 4 also can, but I choose to draw 3. How many positive I draw on the bottom? 3. Okay, so first question, 1 mark. Okay, draw your charges, very easy. Okay, explain subsequently what happens to the small piece of paper. So you cannot just say it flies up or attracted to the rod. Follow my ERO. Okay, so my ERO statement, first thing, have the intro statement. The intro statement is
positively
when the
positively charged rod is brought closer to a small piece of paper.
What do you mean?
intro statement. Always have an intro statement. So there's some context to your question. Don't just I memorize all the important words. Okay? Intro statement. Second thing, E. Okay, Jinglai, tomorrow, E. Talk about electron movement on the paper. Electrons move to where?
Beside the
Move to the paper.
Positively charged.
Now, the electrons don't jump from the rod to the paper. It is within the paper. So the electrons move to the which part of the paper? Where? You see the electrons, the top is what? Negative, right? So the electrons, Jinglai, move to the bottom.
The top.
Move to the top, right? Can you guys
Prop close.
move to the top of the paper? Right? Jinglai, reason?
Because
Unlike-
unlike charges attract.
Because unlike charges attract. Now is because unlike charges attract. Okay. That O. Why is O? O overall effect. Overall effect. Javier, the top is
The top is positive. Top is negative, sorry.
top is negative. Negatively charged. And the bottom.
It is positively charged.
So that is your overall effect, but you cannot stop here. They ask you explain what will happen to the paper. As a result, now this paper you notice is very small. I never take one big piece of paper. So like what AS said, it has to be light enough so that it can be attracted, right? So you have to say the overall effect is as a result what happens? What happened to the paper? The paper?
Small piece of paper is attracted to the charged rod.
Yes, as a result, the small piece of paper, don't say fly out, is attracted to the charged rod. Why? Because unlike charges attract, the top of the paper is negative, this rod is positive, they attract. Okay?
Yes. So, how many
So-
marks will this question be?
Sometimes 2, sometimes 3.
Oh, 2 marks for this.
You can don't do and give up your 2 marks. Right?